Good afternoon. Welcome to Lab 8. We are doing curve fitting this week. So let me see if I can get my slides to advance. There we go. One of the most important things that you learned this week is how to derive a least squares curve fit. So we did this to a straight line in the lecture slides, and kind of quickly going through that, you first calculate these differences or deviations, which is the function you're trying to fit minus the y's, and x and y are your data. So those are actually known values, okay? And then you're going to use that to figure out what, in this case, the slope m and the y-intercept b needs to be. Then you take those deviations or differences and use that to calculate the error, which is the sum of the squared differences, right? And then you want to minimize this. So you want to minimize the error, the total error. And so you're going to take the derivative of this and set it equal to 0, but your variables here are the slope and the intercept, so m and b. So you're going to take dE dm, set it equal to 0. You're going to take dE dB, set it equal to 0. And then you're going to have a system of equations, and then you can solve that for m and b. Now I say it's important that you be able to actually use this technique because in our unit ops courses and occasional other courses, there are opportunities where this will be an assignment for you for other functions. And so you need to know what this process is in order to be successful. So here's another one that you can practice. So if you wanted to do, instead of y equals mx plus b, let's do y equals ax squared plus b. Okay. When you do this, the first step is to figure out what those differences are. So in this case, it's ax squared plus b minus y, and the x's and the y's are specific instances. Then you're going to turn those into an error function, and I left the square off of that, but so it's ax squared plus b minus yi quantity squared, and the sum of that. And then you're going to take the derivative with respect to your variables. Your variables are a and b. X's and y's are constants in this. Okay? So all of the groups that you end up with when you do the simplification of the algebra, those are going to be your constants. And then solve the system of equations for a and b, and you then have your formulas that you need that you could plug in values of x and y. Okay? So try that on your own. The other thing we talk about is R-squared error estimates. And this is going to be a number. It's going to be between 0 and 1. The closer it is to 1, the better the fit. For real data, 1 is a lofty goal. Okay, we're not going to really see that. But we want it to be closer to 1 indicates a better fit. Now, we want that fit to still be rational. So, yeah, if I have 7 data points, I can fit a 6th order polynomial to it, but that's not rational that would be, the best explanation of this data. Yeah, I'll get an R-squared of 1, but that doesn't mean that was a good answer. So you want to choose a curve model that is going to be reasonable for what you know about nature, okay? But the R-squared is a handy way of comparing different models, okay? And the way it can be calculated is listed here in these formulas. In Excel, there are several tools that you can use. Trendline is the one that I use the most often because I can use Trendline to do linear interpolation between just 2 points, or I can use it to fit all the data. Slope and intercept do that for me also. There's going to be forecast we'll look at next week. RSQ is going to calculate the R-squared value. LinEst and LogEst are going to do a formula that's in a linear form, and you can actually do polynomials or a logarithmic form. So y equals ln of x plus ln of x squared, etc. You can do those type of forms with linest and logest. And then there's the regression tool. The ones you probably want to kind of focus on in terms of for future use, the slope and intercept are the most useful for getting quantities if you have a linear fit. The regression tool is the best if you are wanting to be able to do full analysis. And again, when you take those UnitOps lab courses, the regression tool is going to be the one that's going to be most helpful to you. Trendline is useful, but just as a quick way to visually compare various alternatives. And you can get it to show you your R-squared value for the various alternatives, so that's nice. So what are we going to be doing today? Well, we're going to be taking looking at the reaction rate of Alka-Seltzer and water. And so what I'm going to have the students who are here in class do, and if you're at home, you could try this, but frankly, you're not going to have a scale that's going to do a good job. But they're going to measure out a small portion of water, and they're going to have an Alka-Seltzer tablet. They're going to take the mass of the Alka-Seltzer tablet, then lift that off the scale, put the cup of water on the scale, record the mass, drop the Alka-Seltzer in the water, and begin recording the mass as it changes, okay? And if you record that mass every 2 to 3 seconds for about 5 minutes, you'll get a great graph of mass versus time, and then I want you to do a curve fit of that data. For those of you participating from home, I'll give you a link to a video that you can watch that does this same thing. Okay, so I think that's it for today. Thanks a lot.